Now that we have our chart in hand from the red beads, we can make further studies of the red bead. Interpretation of chart. The process exhibits good statistical control. What do we mean by that? That the points, the work done by our willing workers stayed within the control limits, no point outside. That's part of it. This conclusion, now listen, this conclusion is based on intimate knowledge of the procedures prescribed and followed by the 6 willing workers, as well as on study of the chart. The chart alone is not enough. We must understand the procedures that produced the point. And we understand, we listen to the foreman as he gave instructions and taught the willing workers their jobs. We have here an example of a constant cause system. Constant cause system. A variation, system of variation. Nothing special, no point outside. All that happened came from the system itself. There's no evidence that one willing worker will in the future be better than any other. Differences between willing workers and between days are attributable to variation inherent in the system, common causes of variation, or, if you wish to call it, constant causes of variation. That is nothing special. Now here comes a very powerful statement. The willing workers have put into the job all that they have to offer. The willing workers have put into the job all that they have to offer. They can do no more. Why do we say that? From the chart. Stable process. Constant causes only. In the state of statistical control, the willing workers, people on the job, have contributed all that they have to offer. They can do no more. That's it. They say, well, they have ideas on what to change. They might have some good ideas for improvement of the process. Yeah, you're right, but they were not permitted to use them. The foreman would not listen to any suggestions. It was his job to produce procedures, and he did. He taught them, the willing workers followed them. Anybody that departed from procedures lost his job. May I read it again? The willing workers have put into the job all that they have to offer. Powerful statement. Dr. Duran made that statement around 1954, as I remember it. Powerful statement. One way to decrease the proportion red in the product would be to reduce the proportion red in the incoming material. At least I should think so. Management's responsibility to work with the supplier. Now, the control limits may be extended into the future as prediction of the limits of variation to expect from continuation of the same process. Those limits, upper limit 18, lower limit 1, we may extend those in the future if we had the paper long enough. Well, the paper, so we don't try it. We're going to extend them in the future as prediction. That's a great advantage of a stable system. Now, by stable system, I mean in statistical control. By stable, I mean the variation is stable, dependable. It'll be between those limits. Now, we have not the future. We only have yesterday. We have not the future. The future would require us to get the willing workers back again for another 4 days, another 8 days, maybe 20 days, or get 6 willing workers. Need not be the same ones. I'll ask you a question a little later. Why would any 6 willing workers do? Any 6 willing workers. We don't need the same ones. Now, we have not another 4 days. We have not another 8 days or 20 days. But I had in hand data from Nashville. I plotted those data. Same beads, same paddle, same foreman, different willing workers. So happened that the control limits for Nashville were 18 upper limit, 1 for the lower limit, just as we got yesterday. Now, don't go away thinking that the control limits will always be 18 and 1. That's not so. They might turn out to be 19 and 2 if we were to repeat the experiment. They might even be 19 and 1, but to be close to 18 and 1. Now, yesterday was future to Nashville. So if I extend the limits from Nashville into the future, yesterday was future to Nashville. Behold, my prediction holds. The results for yesterday fell within the control limits for Nashville. I predicted from Nashville that future variation would fall between 18 and 1. Yesterday was future to Nashville. Behold, prediction confirmed. Now, sometimes something will happen. Let me ask you a question. Suppose you got 20 red beads. Suppose somebody produced 20 red beads yesterday. What would you say happened? Well, it will happen. If it were to continue for years and years, somebody would produce 20 red beads, possibly 21 or 19, outside these limits. What could be the explanation? It just happened. Or maybe the inspectors counted wrong. Get up to 17, 18 red beads, it's hard to count. Maybe the inspectors made a mistake. That could be it. Too late. Never be able to recount them because they're dumped back into the bowl. I've seen it happen. Explanation? It just happened. It's one of those instances. One time in years and years, a point will fall outside the control limit from common causes. But you must assume, first of all, special cause, something special. Now, if you're not willing to believe that there was anything special, then it can only be from common causes of variation. I'm afraid if I upset you, I'm afraid I'm upsetting you just a little bit, because this is very rare, extremely rare that you find a point outside the control limits that we found yesterday. We'd have to experiment for a long, long time to find it. But it could happen. I've seen it. You see, once in a while, Nobody knows how many. One time in 500, one time in 1,000, nobody knows. A point will go outside the control limits when there is no special cause. One time in 500 or 1,000, nobody knows the figure. A point will fail to go out beyond control limits when there actually was a special cause. And nobody knows those frequencies. If you have a book that tells you those frequencies, tear those pages out. Just not so. I put the names along the side so that if we want to ask any questions, we could do it. Now Shirley went up to 14 red beads one day. But she had only 5 red beads, 7 red beads the day before. And the next time Shirley came around, went down to 9. The highest one of all is Ken. But look at Ken. He was not all this high. Did pretty good work. I put the names along the side so that we could take a look who did what, if we wish to. Now I calculated an accumulated X bar, average number of red beads per workload. For the first day, 53 red beads, 6 workloads. 53 divided by 6 is 8.8. Put the first 2 days together, 53 and 61. Divided by 12 workloads. Goes up to 9.5. Put the first 3 days together. Divided by 18, or 18 workloads, you get 9.1. Put all 4 days together, you get 9.3. Now, suppose that you have a stable system, and we do. Will accumulated X bar settle down to something? Yes, it will. Settle down to some number, or close enough to it. Now, how many red beads were there in the incoming material? What would you mean by the count of red beads and white beads in the incoming material? What would you mean by that number? Number total, number red, number white. What would you mean? You say just count them. Did you ever do it? How many here have taken part in inventorying process? Yeah, nearly everybody. Did you count everything? Of course you didn't. Why not? Because counting is difficult. Well, if you count, you get 57 items. Somebody else count, you get 59. Counting is difficult. So we avoid it so far as possible. We use a multiplying scale. But you could count all the beads. You could, one by one, census count. You could transfer the beads one at a time, one vessel to the other, and as you transfer the beads one by one, mark to keep a tally as you go along. Might as well separate red and white. How we do it? White and red, one by one, as they go along. Got one here, there, then a red one, so on. We could do that, one bead at a time. Census count, one by one. Not just count them, but while you're doing it, classify them red or white. If you do that, you get a total of 4,000 beads. Red, 800. White, 3,200. 20% red. 20% red. Let me ask you this question again. Accumulated X bar. If we were to accumulate, not just 4 days, 8 days, 20 days, 32 days, 40 days, if the system is in statistical control, then X bar will settle down to something, some number. What might that number be? What might that number be? I hear weak choruses. Some people said 10. Where'd you get that 10? 10 to 20% of 50. What kind of sampling did we do yesterday? What kind of sampling was that? Huh? What was it? It was not random. It was not random. That's my point. It was not random. It was mechanical sampling. By mechanical sampling, you'll never know what was in that bowl. By mechanical sampling, you'll never know what was in the lot. How would you do random sampling? How would you do random sampling? How many here have ever had a course, an elementary course in statistical theory? Huh? No, don't be ashamed of it. Yeah. Nearly everybody, yeah. And your book and your teacher talked about random samples, and neither one of you told them how to do it. They talked about equal probabilities. I gave you no clue on how to do it. No clue on how to draw a random sample. They didn't tell you. You didn't learn. You never thought about it till right now. You never realized you didn't know how. Not till this very minute. You didn't know how to draw a random sample. You just talked about it in the book, and your teacher talked about it. Neither the author of your book nor the teacher knew how. That's why. Now let me tell you how you could draw a random sample of 50. You could put a number on every bead. Take those beads, put a number on every one. 1, 2, 3, 4, 5, so on. Up to 4,000. Now, open a book of random numbers and read me random numbers. The first random number is 235. All right. Then I reach in, I find bead number 235. I put in the sample. The next number is 3123. I find bead numbered 3123. And I put it in the sample. I continue till I have a sample of 50. Now that would be a random sample of 50. You see, you'd have to create a frame, a list of the beads, one by one, so that you could find it identifiable, and you'd have to use random numbers. We did no such thing. That was mechanical sampling. And by mechanical sampling, you'll never know what was in that bowl. By random sampling, you would. If we used random sampling, then X bar would settle down to 10. We did not use random sampling. We used mechanical sampling. And we do not know what X bar will settle down to. We have only 4 days. Average of 9.33 for the 4 days. Now, what are the big lessons from the red beads? The willing workers have put into the job all that they have to offer. They can do no more. Foreman kept pleading, begging, threatening. Wants more white beads. Management put a lid on it, not more than 3. It was all nonsense. The willing workers could do nothing. They were totally helpless. They put into the job all that they had to offer. All that happened came from the process itself. Thoughts from a willing worker named Anne. Anne was a willing worker. I do not know her name. I made no record. I'm not sure what company she was with. She told me after the experiment her thoughts, her emotions, how hard she tried to do better. I said, Anne, please sit down and write to me. Just write what you've told me. Don't make it fancy. Just write words as they come to you, just as you told them to me. She did. And here's her letter. When I was a willing worker on the red beads, I learned more than statistical theory. I knew that the system would not allow me to meet the goal, 3 red beads. But I still felt that I could. I wished to. I tried so hard. I felt responsibility. Others depended on me. Others depended on me. I'm going to try to keep the place open, otherwise we'll all lose our jobs. My logic and emotions conflicted. I was frustrated. Logic said there was no way to succeed. Emotion said I could by trying. After it was over, I thought about my own work situation. How often are people in a situation that they cannot govern, but wish to do their best, and people do their best. And after a while, what happens to their drive, their care, their desire? For some, they become turned off, tuned out. Fortunately, turned off, tuned out, demoralized, follow me around. There are people demoralized, totally demoralized, just waiting for retirement. Fortunately, there are many that only need the opportunity and methods to contribute with. We had in the red beads a horrible example of the worst procedures that anyone could put together. It was done purposely. I made it that way purposely to make the point. The foreman was in total charge. The management gave him the job to come through with procedures. The foreman did. He enforced the procedures. The worst procedures it could be. The workers were not allowed to make any contribution. Any departure from procedures would result in dismissal. Somebody took one worker, Richard, took a second dip. A lot of red beads, first dip, I'll take a second dip. Lost his job. Somebody lost a job one time because he took a red bead out of the paddle and was replacing it with a white one. Against the rules, out he goes. Now don't jump. What would be the cost of the second dip? What would be the cost of a worker pull a red bead out of the paddle, replace it with a white one? I don't know. Figure it out. Would that be a good procedure or not? It might be. It might be. But the workers had no chance. A fellow named Dave in Cadillac pointed out that everybody that got fired from the red beads, all the experiments he'd seen, did exactly what people will do on the job. They take a chance on the job of improvement. May cost them their job. What we saw in the red beads was the worst procedures possible, just about the worst as there could be. And they did it purposely to make the point. The willing workers put into the job all that they had to offer. They could do no more. And I'd like to turn to page 68 in the book Out of the Crisis. I think we can understand it right now. Page 68. The chart at the top. There were two charts. We'll only study the one at the top. They both have the same principles. These charts were 6 feet high on the wall for everybody to see. The points show the proportion defective in a week. Every week for the past 6 months. Every week, a new point would go on at the right, and one would roll off at the left to show the workers how things are going. Now, what's wrong? You might say, well, don't the people need to know when they wish to know how they're doing? Well, maybe that wouldn't do them any good. They wouldn't learn anything from it. But what's wrong? That goal halfway up, goal, heavy red line, halfway up. Management asking them to reduce the proportion defective down to that red line. What is the effect of people that would take a look at that chart? Now, they have not been to this seminar. The willing workers that would see that chart, they have not been to this seminar. But they understand the chart. They understand it. They understand the goal. They understand they're asked to do what they cannot do. The management is asking them to do what they cannot do. What is the effect? Humiliation. Can't do the job. I'm not needed. Can't do the job. Not necessary. I'm not necessary. I can't do the job. What's the effect? In the first place, you don't get the goal. Second place, demoralization. How much quality suffers, nobody could know. The damage would be one of those things you cannot calculate. Quality would suffer from a lot of reasons. In the first place, the people there would only work for the money, just for the money. He can't do the job. He certainly could not take pride in his work. He can't do the job. He works for the money. The manager asked a man why he worked 4 days last week. The manager was trying to find out why he did not work 5 days. Why did he work 4 days last week? Well, you cannot live on 3 days. Needed the money for 4 days. Working for the money. Not very good motivation. The damage in quality, absenteeism, nobody could measure.